So the remaining n minus r minus 1 objects is distributed in an arbitrary way. Is distributed arbitrarily in, so you have r plus 1 boxes, so including the first and last. So therefore the number of ways will be equal to, so that is the number of ways of distributing n minus r minus 1 objects into n boxes. So repetitions are allowed. So therefore you will get, so that is in the form of h and r. So you will get n minus, so this is 2r minus 1 plus r plus 1 minus 1 then you have n minus 2r, this is plus 1. So that will be equal to n minus r plus 1 c n minus 2r plus 1, or this is also equal to n minus r plus 1. If you have NCR, NCR will be equal to NC n minus r. Okay. So that will give n minus r plus 1 minus n minus 2r plus 1. So that will be equal to n minus r plus 1. So n will cancel off and 1 also will cancel off, remaining you have r. So that is the required result. So the number of ways will be n minus r plus 1 c r. And next problem is, so let r n k belongs to n such that r greater than or equal to nk. Then find the number of ways of distributing r identical objects into n distinct boxes so that each box holds at least k objects. So here you need to find the number of ways of distributing r identical objects to n distinct boxes such that each box holds at least k objects. So r is greater than or equal to nk. അപ്പോൾ നമുക്ക് total n boxes ആണുള്ളത്. n boxesൽ ഓരോ ബോക്സിലും at least k objects ഉണ്ടായിരിക്കണം. So there every box must have at least k object. അപ്പോൾ എല്ലാ ബോക്സിലും minimum k എങ്കിലും ഉണ്ടാവണം. So here the number of objects, അപ്പോൾ എല്ലാ ബോക്സിലും k objects ഉണ്ടെങ്കിൽ so total you will have nk objects. So here we have r greater than or equal to nk. So what we do here is, അപ്പോൾ ആദ്യം എല്ലാ ബോക്സും at least k objects ഉണ്ടായിരിക്കേണ്ടതുകൊണ്ട് we will place k objects in each box. So that will become now total nk ഇനി ബാക്കി നമുക്ക് ഉള്ള ഓബ്ജക്ട്സ് എന്ന് പറയുന്ന r minus nk. So these r minus nk objects can be distributed in an arbitrary way to the n boxes. So that is the required number of distributions. So first the solution is, so since each box holds at least k objects, so first put k objects in each box and the remaining, so remaining there will be r minus nk objects. So the remaining r minus nk objects can be distributed in an arbitrary way to n boxes. So that will be equal to, so you have total n boxes and you need to distribute r minus nk objects. So therefore the number of ways will be n plus, so in place of r you have r minus nk, so that is of the form n plus r minus 1 cr. So you have n plus r minus nk minus 1 c r minus nk. So that will be equal to, okay, n plus r minus nk minus 1 c r minus nk, or you can also write it as n plus r minus nk minus 1 c n minus 1. So that is the required number of ways. And let us see one more problem. So how many ways are there to arrange the letters of the word visiting if no two eyes are adjacent? So no two eyes must be adjacent. So we have the letters VT, VST and G. So eyes can be placed in these 6 positions. No two eyes must be adjacent, so they must be between these 5 letters. And now the 5 letters V, S, T and G can be arranged in 5 factorial ways, and I can be placed in, so for placing I we must choose 3 places out of 6, so I can be placed in 63 ways. So therefore by multiplication principle, so the number of arrangements will be, so take the product of this, so that will be 63 into 5 factorial. So that is the required number of arrangements.